All right, here we are in 5E. Wow, these are taking about 11, 12 minutes for 6 minutes a page. I feel like I'm blowing through it. All right, let's crash our toys together. Parents will ground us. We have 3M and mass of M, and they're going to travel and they're right and left, and they collide and stick together. Oh, wow, they're like Play-Doh cars. So we're diagramming the situation. So the momentum graph for the little guy, since it's going to the left, it's on the it's below the line. So it's got a negative velocity of v. So and then it's got one, two. What? Why is it four? The car's initial momentum, m and v. I guess we're saying v is 4 blocks. They both have 4 blocks of velocity. Sure. I don't know why. Maybe it just makes it easier to see. So 1 unit of mass and 4 blocks of velocity gives a blue rectangle that looks like that. It's negative, so it's below the line. The truck has got 3 units of mass. I see that, 1, 2, 3, and 4 in the same number of units of velocity, so it has to have the same units of velocity. So its rectangle looks like a 3 by 4. And then afterwards, red and blue make purple. That's not politically correct. So basically, afterwards, the final momentum will be a combination of we have 4 blocks of blue, which are negative blocks, and we have 12 blocks of red, which are positive blocks. So we should have 8 blocks left over. Notice that we have 4 blocks of mass because 3 plus 1 is 4. 3 blocks of mass, 1 block of mass, 4 blocks of mass. If we have 4 blocks of mass and we have 8 total, then we should have a little box that's a 4 by 2 box. So it all makes sense when you see it, huh? In which direction will they be traveling after they collide? I'm thinking it's got the momentum is positive after the collision, so the direction is positive. Oh, look at me. I got it right. We're still on E. They're now pressed together with an ideal spring compressed between them, and they're released from rest, so it's going to explode. And we're going to diagram the momentum before and after the explosion. So before, the momentum is 0. There's 4 units of mass with 0 velocity. So it's a line, right? It's a two-dimensional line. After the explosion, the car is going to have 1 unit of mass. The truck is going to have 3 units of mass. Their momentum has to be the same because they have to balance each other. So the left and the right momentum have to be equal. If the car has got 1 unit of mass, it's got to have 3 units of velocity, and the truck has 3 units of mass, it has to have 1 unit of velocity, so that the momentums are both equal to 3. 3 positive and 3 negative, and notice that one's up on the top and one's below the line. One's got positive velocity, one's got negative velocity. And it has to be 3, right? Because it's 1 times 3 and 3 times 1. What if it was different? What if we had said the velocity of the little one was 6, then the other one would also have to be 6, right? I think as long as this rectangle is at the 1 on the mass, and the rectangle here is at 3 on mass, as long as the area of the blue and the red are equal, you did it right. This may not have to be exactly like this. Momentum before as well as after. What is this? Why is there an energy thing here? The energy, because it tells us to. Okay, so before, the energy is all spring. And then afterwards, you can see that the car has 1/2 mv squared energy. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1/2, the mass is 1, the velocity is 3. 1, 2, 3, squared is 9. And then that's this one. Okay, the blue one. Okay, I was going to say what? Right. So, anyways, it looks like the truck just has 3 times as much kinetic energy as the car has. Now the car is red and the truck is blue. What? Oh my God! People, you're killing me here. Blue car, red truck. red car, blue truck. Okay, I'm just moving on. I can't do this. If there are two identical cars and they collided and they stuck together, well, they had the same mass, they had the same speed, they would stick together and they would have zero momentum afterwards. There you have it. There you go. Oh, let's see. We're already at 5 minutes. Look, we're going to crash our cars together again. So the toy car is at V, and now we're going to bounce the car off the truck, so the car's final speed is half. Consider the system car and the truck. So the initial momentum of the car is 1 unit of mass, and I don't know, that looks like 2 units of mass. I don't know. And there's so it's got a negative velocity because it's going to the left. The truck's just sitting there, so it has no momentum, but it's got mass. So they're going to take the truck's mass out to 1, 2, 3. So I guess every two lines is 1. So this is a half, 1 unit of mass, 1/2, 1, 1.5, 2, 2.5, 3 units of mass, whatever. Afterwards, we're said the velocity is cut in half and it's bounced in the opposite direction. So now it's got 3 units of velocity, but it's positive velocity. It still has 1 unit of mass, 1/2, 1 unit of mass. So if this has 1 times whatever this is, 1, 2, 3, 4, 5, 6, 7, 8. This is basically 8 units of negative momentum. Afterwards, we have to have 8 units of negative momentum. So here we have 1 times, or 1, 2, 3, 4 times 1. We have 4 units positive momentum. So this momentum and this momentum have to add up to this area, and this area equals this area plus this area. So this would be 1, 2, 3 times 1. I don't know. It doesn't feel like it works to me. It seems like the car's negative momentum. Well, what happens next? Here's the initial momentum. Here's the impulse applied to the car. Here's the car's final momentum. Oh, we did this lab in class back in the old days when we used to have class. We would drop the ball onto a different surface, and we didn't have well, I guess we could have had a force. Maybe we'll try that someday. What quantities would need to be graphed to exhibit a straight line relationship? So force equals change in momentum over time. That comes from delta P equals net times time. So if the net external force is graphed versus 1 over the time, the slope will be equal to the change in momentum. Yeah, so you have to graph force versus the inverse of the time. And what are we at? Well, in keeping with the spirit of the thing, we've done 2 pages, even though it's only been 8 minutes, so let's just stop.